Exercise 6. We've got a Gallup poll report that's telling us this key fact here. 72% of teenagers say that they seldom or never argue with their friends. Vani wonders whether this result holds true in her large high school. So she surveys a random sample of 150 students and finds that 96 of these said they seldom or never argue. So you need to realize the population that we're interested in, our population proportion that we want, P, this is the proportion of students who never argue or seldom argue in Yanni's high school. So just please understand, we've got the population proportion for the general country from this poll report. We're going to assume that. We want to know about the population the proportion in her high school. So we're asked to begin by stating the null and the alternative hypothesis. We might, before we do that, we might go ahead and compute p hat. From the sample, we can see that, okay, 96 out of the 150 say that they rarely or never argue. You can compute that and get 0.64. And now we can state the null and the alternative hypothesis. So the null hypothesis is there's no difference between her school than there is in general. And so we know the general proportion is 72%, so we expect the proportion in her school to be 72% as well. So the null hypothesis is p equals 0.72. The alternative hypothesis is actually no, there is a difference. And if you look at this problem, it doesn't actually say the word there is a difference, but nor does it say she thinks that more students argue, she thinks that less students argue. She simply asks if this result holds true in her large high school. And so it's either true, it's the same, or it's not true, it's different. And so this actually is a two-sided test. So the alternative hypothesis is P is simply not equal to 0.72. Now we're asked to perform a significance test in part B and say the conclusion. So we begin always by computing our test statistic. And so Z in this case, let me remind you of the formula. So the formula for the test statistic with proportions is your p hat minus p naught. P naught is the null hypothesis value. So that's just your 0.72, which we're going to fill in just a minute, divided by the square root of p naught times 1 minus p naught all over n. So when you actually go to plug this in, I typically wouldn't write the formula down on a test. I would just plug everything in, but I wanted to show you here. You're going to get Z equals, 0.64 was our p hat minus 0.72. Then you're going to divide by the square root of 0.72 times 0.28 all over, she sampled 150 students. So that's what you get. Crunch the numbers on this and you'll get negative 2.18. And now we need, I'm not done, that's just the statistic. A lot of students make the mistake of stopping there, and if you think about it, that's a strange p-value. P-values are area. They have to be positive and less than 1, bigger than or equal to 0, less than or equal to 1. So because this is a not equals, then we're going to actually want to compute the probability that big Z, two times the probability that big Z is greater than or equal to the absolute value of negative 2.18. Same thing is 2 times the probability that Z is greater than or equal to 2.18. And so when you compute this, you're going to get 0.029 when you multiply by 2. So that's your p-value. That's pretty small. It's certainly less than the sort of the 0.05. We've talked about many times how 0.05 is probably too big in some ways. So the way that we typically answer this, if we're not given a clear, hard, fast significance level, then we want to go ahead and state it just in terms of evidence. So we can say that there is evidence to reject the null hypothesis. In other words, i.e., there is evidence, or let's say it like this. Let's say that the data suggests that there's a different proportion at Yanni's high school. And that's it. maybe I'll box reject the null hypothesis. There we go.